So, good evening, good afternoon, good morning, everybody. Today we are going to discuss about the IPSec overlapping subnet, and then we will do IPSec with NATing. So we'll see what are the consequences when you do a NATing with IPSec, and also how we can do an overlapping subnet. So before that, let me give you a quick background about what we are going to achieve today. And I would like to start with this. It is one of the, most of the interview questions. It's how your IKE phase 1 and IKE phase 2 tunnels are built and how exactly happens. And as I discussed yesterday, we have gone through every packet and how exactly the phase 1 and phase 2 tunnel, how to build your phase 1 and phase 2 tunnel, and what are the key materials that's being exchanged between your initiator and responder. So we say that an haggle is a parameter, and as I said yesterday, haggle stands for your hashing algorithm, and then followed by that your lifetime and encryption. So they are your security parameters. It should match on both devices. So what happens when you try to build your tunnel? This is an initiator and this is a responder. So it will look for your negotiation. Is it the IPsec tunnel is built with NAT-T? Is it you are doing a NAT? If you are doing a NAT, then the NAT negotiation happens between the source and destination. So this all happens in main mode 1 and main mode 2. Main mode 1 comes from your initiator to the responder. So let me take a pen. So this is main mode 1, and right over here is your main mode 2. So your all your haggle parameters is exchanged. We discussed this about yesterday, but along with that, today we are going to do about the NAT-T. So if NAT is supported, if you are doing a NAT, it detects. So it detects automatically. If you have your NAT, it detects your NAT. So followed by that, as I said, your main mode packet 3. So they expect you to explain from every packet. So yeah, main mode 1 packet is sent from the initiator sends this main mode 1 packet. So it has its security association. So it will share all the key materials. If I say key materials, your algorithm, sorry, your hashing, your lifetime, your encryption. So generally we do hashing, encryption, and we will be using a pre-shared key or certificate-based authentication. So all your security parameters, that's called as an haggle parameters. So the haggle parameters, the initiator, he proposes all his haggle parameters to the responder, and the responder with MM2 packet, he will respond back with the same haggle parameters. So if both matches, only then it goes for the main mode 3 packet. And if you see, as I said yesterday, until MM4 packet, they are all non-encrypted. So what exactly happens here? So the question 2 is, so once the haggle parameters is exchanged and you established, I mean not established, your M1 and M2 messages are being exchanged between the initiator and responders. Once it is done, so it comes for MM3 packet from the initiator again. So here he will share the Diffie-Hellman group here, right? DH group. We define the group command. So here we are actually telling that, so what kind of group I'm going to use for my session keys, right? So you should tell them the session keys are being exchanged. So what kind of group I'm going to use? This is used for your session keys. So it's called a shared secret. So they all see, if you see, this is nonce I stands for the shared secret sent by the initiator and nonce or sent by the responder. So both share the key and they come up with a Diffie-Hellman key here after this successfully. If both are using the same Diffie-Hellman algorithm, then you will get your shared secret key at this point. So until this message 4, it is not encrypted. That is very important to understand. So after that, what happens? This is we are again talking about only the phase 1, IKE phase 1 here. So we are on message 4. And then coming back to this, so once the session key is exchanged, so now the whole packet is started encrypting. So your MM5 main mode 5 packet, and this is MM6 packet. This is your responder. This is your initiator. So once this is successfully happened, only then you build your actual IKE phase one. So when you look from the troubleshooting standpoint, when you have some problem with I mean, if your responder doesn't have a, I mean, let me draw this. So you are using Diffie-Hellman group 2, and he's proposing Diffie-Hellman group 4 example. So at this point, your your packet I mean your tunnel may get broken, or you cannot establish a tunnel at this point. So the security parameters should match on both ends. So there exactly, if you see your haggle parameters, and if something is failing with this, if you are sending your nonce message and you are not receiving the nonce message from the responder, so you have to look into the device on the responder device. You have to check your what kind of Diffie-Hellman group he is using it. That's how you can troubleshoot. So when they are asking a question about that, so you should explain about all these packets, and it should be a very sequential. I mean, I mean, you have to start from the packet one, and you should finish up to your packet 6. So there are totally 6 packets exchanged. If you calculate this, totally you got 6 packets. 1, 2, 3, 4, 5, 6. So then after this, yeah, after this it goes to quick mode idle state. And as I said, why it goes to idle state? Because your session key is created at this point. After your main mode 6 packet, that comes your quick mode idle, because it created a session key, and until the lifetime expires, it's going to use the same key. So once it expires, it goes for the again the Diffie-Hellman wakes up and he creates a key. Those shared secret key is exchanged between the initiator and responder. Then your tunnel stays up. So that's how your tunnel reestablishment happens. That happens very quickly. That's called as quick mode. So that's how you should actually explain your IKE phase one tunnel. That's really about a quick background about what we did yesterday and what we are going to achieve today. So what are the consequences of doing an NAT? So that's the whole point here. Okay, so so this is my IPSec tunnel. So I got an ISP in the middle. I got many devices, many routers like this interconnected. Let me make it a one single cloud. So this is your ISP. You have a connection like this. So this is called an underlay connection. So you start building a tunnel. So your tunnel goes like this, your IPsec tunnel. So you have successfully built your IKE phase one and your IKE phase two. So the key information, what we should know about. So in your IKE phase one, we know that we should have your UDP port 500 should be opened for your ISAC amp. So that is the protocol used, and it is talking over port UDP port 500. And when coming back to the phase two, so it actually uses a UDP port 500 when you're using NAT. So now let's talk about what are the consequences of doing a NAT when I'm running an IPsec. So we all know that, I mean, NAT maintains its own session table. Example, a traffic here in the LAN segment that's hanging over here. Sorry, it's hanging off on the router one, and this is router two. For example, this is 10 network, right? So this is a 20 network. So, and let me change the color. So right over here, this your egress point exactly here. You do your NATing. The same way you do a NATing over here. So the biggest problem is if I am sending a traffic and it maintains its own session table. So what happens here? It is trying to do. I mean, it uses. I mean, the NAT has its own port translation, right? So, example, if your traffic is coming from 1001 and it is using a random port number 3826, and it is actually overloaded to your public IP address, your egress point exactly over here. That's something 90001. Our example, the outer header 90001, and it uses the same port number 3826. So it is overloaded with the port number. For every device, it has a unique port number. So while coming back, it does the reverse translation based on the same port number. But the biggest problem here, when this NAT exactly happens, right? So you're trying to tamper your ESP packet because your IP packet is encrypted completely with the ESP. Your private IP header sits right inside this. Example, in our example, this is 10.0.0.2 is over here, a device it's connected. 10.0.0.2, and NAT is trying to tamper this packet, so that is not allowed. So generally we use UDP port 500. So that's when your phase one exactly happens, your NAT discovery happens, NAT discovery happens. So if it is doing a NAT, instead of sending this traffic over UDP port 500, so what exactly happens here? It has its own new header created with UDP 4500. And here exactly your outer packet is again routed, not your inner packet. So as we discussed in the previous classes, you got a two header. One is your outer header and your inner header. So your outer header will be intact with your UDP 4500. So when it does a NAT discovery, it look for it. Okay, I see that it's coming from UDP port 500. So I'm not going to tamper this traffic, but your ESP traffic in the sorry, your ESP packet, that's that is again not tampered. So this is going to allow this outside header. So your NAT translation happens. So it detects when your IKE phase one happens, it tries to detect. So we will do this in the lab. You'll understand better. So your NAT detection happens in phase one. If you actually see this, if you go back to this, so the NAT detection exactly happens in your, the phase one tunnel. You can see this NAT-T. If it is supported, then it happens actually automatically when your NAT discovery happens. So your new header is created with UDP port number 4500. So the whole point is your ESP packet should never be tampered. So it creates its own, as I said, it creates an outer header with UDP 4500. So your packet is allowed for NAT traversal. So that's the whole point of NAT traversal, and let's see how to do that. And there are different way of doing it. I'll discuss about that in the lab. So let me explain this topology a bit. So I have an ISP here. So I build a tunnel between R3 and R1. So I created two loopback interfaces. This is used for our NATing. Um, First, let me explain what I did. Then we will wipe out the config and we will rebuild the config from the beginning. We discussed about the phase one and phase two packets yesterday, so I'm not going to not talk much about the phase one and phase two tunnels now. So we are most focusing on the IPs, I mean NAT. So how we are doing in NAT and how we are achieving it. So, as per the content, we have two discovery. One is we are doing IPsec with overlapping subnets and NAT. So let me first explain NAT and how I build the NAT. If I give show run, if I give show run section ISACamp, if you actually see that I mean, I created the same tunnel. I didn't create any new tunnels here. So I'm using the same thing what we discussed yesterday about that. I'm using the hashing 256 encryption is AES 256, and we are using a pre-shared key Cisco. And my peer is here. If you look at this, this is 20 network, a WAN connection between R3 and R1. So I'm making a peering with this guy 20.0.0.3. And if you see the this is the crypto map. So I'm stitching my IPsec with ISACAM. So on top of that, so I have to show you this section transform set. So this is your phase two tunnel. So crypto IPsec transform set, and then I'm using the null encryption ESP, and here I'm using the hashing SHA-256 hash. So I want to call this transform set Cisco right over here in my crypto map. Then finally I have to apply in the interface. So I applied on the interface Ethernet 0/2. Show run interface Ethernet 0/2. So you can see this crypto map Cisco. So I created a crypto map with the same name. This is my name, crypto map name. So I've applied in my outbound interface. My outbound interface is Ethernet 0/2 right over here. So if you look at this, this is the interface where I created this. I have applied my crypto map. This is my outbound connection going back to this R1 right over here. So I applied the crypto map on this outbound interface. Then show run section NAT. So here exactly I created a NAT. So I'll tell you, I created a two NAT, one for overlapping subnet. If you actually see the loopback interface right over here, I got two loopback interface with the same IP address. On R3, this is actually, we are just trying to depict like this is a server. So I have a server with the IP address 1.1.1. So I'm doing a translation. This is a destination NAT. So what are the traffic that comes and hits for 20.0.0.6? Because I have an user in the internet and he cannot talk to my private IP address directly. So I'm doing a destination NAT, and we know that destination NAT is an inbound traffic. We discussed about this in the lab. In the NAT lab, we did that. So the packet flow is actually, this is a PC here. So this is a PC, the PC traffic coming to this interface. This is an inbound connection. So when the traffic initiated from the outside to inside, so it comes and hits my outer header, my public IP address, and that's again translated to 1.1.1. We'll see that when we do it. We'll see that how this is exactly translated. So the whole objective here is, example, you have been given with a task, maybe in the future, or example, you just imagine, you have given with a site migration where you have your you build a IPsec tunnel, but you have a problem that both servers are using the same IP address. If you look at this, so I got two servers. So this is on R3. There is a site. This is a site one, and this is site two. So you got two sites, and you have built a IPsec tunnel, and you have your loop. I mean, you have your server with an IP address 1.1.1, and you have one more server the same IP address here. What if a traffic, if somebody is trying to access this device, this server, right? So where exactly the traffic goes? So even if my client local connection, if it goes, it will not, it will not egress out to my external interface. So everything happens here. So we don't need an NAT. But what if an user from on outside, he comes to try to talk to this? So if you look at this, so I made a destination NAT translation for this public IP address 20.0.0.6. It's on R3. This 20.0.0.6 is mapped to this server on R3. And also when you look at the config on R1, show run section NAT. So if you compare this values, how do I do that? I think I can keep it here. You can see this, the public IP address is different here. Let me copy this and paste it over here. So if you compare, this is on R3, right? So this is on R3, correct? And this is on R1. So the only difference you can see, the my LAN IP address, both server has the same IP address, but on the R3 device, I am using a 20.0.0.6. I'm translating the 20.0.0.6 to this server. So example, a PC from outside, right? So he is trying to establish a connection to this guy 20.0.0.6. So that's translated, and it exactly comes to my R3 right over here. It goes to R3. An outside user is trying to access 20.0.0.6. It will go to R3. When somebody else, I mean, who's trying to access 20.0.0.11, it goes to R1, because we are on R1 here. It's purely a destination NAT, and your traffic is coming from outside to inside, and it's an inbound traffic. And here we are using a NAT. As I said, it should detect the NAT translation, and it should allow. It should not tamper your private IP address. So that applies only to your outside interface using UDP port 500. So how do I achieve that? Show run, show IP access list. If you see this, I allowed the UDP port 500, and also I allowed UDP port 4500. If you see, both are UDP ports, and I allowed only the traffic between 3.3.3 and 1.1.1. So as I said, if a traffic from a user that comes for this private IP address, so this translation happens only within the device, right? So this is your outside, and this is your inside. So a user who is coming from outside, he is trying to hit the public IP address. If you look at this, this is 20.0.0.11. but when it comes inside, it's translated back into 1.1.1.1. Correct. That's how the translation happens. Now let's see this in action and how this NAT-T happens. Let's see first. Let me try to flush the not flush. Let me try to purge the IPSec tunnel, and we'll see the NAT discovery. So don't worry, I'll give this config. You guys can have a backup of it, and you can try at your home. So I am on R3 right over here. So I am trying to here is an R1. So if I give show run section NAT. So I want to access this server on R1 that's hanging off on R1, the 1.1.1, but I am coming from here. A user is coming from this server 1.1.1 is trying to talk to this guy 1.1.1. Both have same IP address. And let's see how we are going to achieve that. Before that, let me try to run the debug command to see the translation debug IP NAT on R1 because it's an inbound traffic. So inbound traffic to R1. So I'm going to initiate a traffic from R3. So let me ping let me ping this guy 20.0.0.11, your outside header. So if you see, I tried to ping 20.0.0.11, correct? So the traffic here, it's coming from the outer header. If you look at this, this is 20 network, and this guy is 20.0.0.1. This interface here, correct? He's coming from their source, and destination, it tries to hit 20.0.0.11, and it is translated to 1.1.1.1. Because if you look at this, even I have in R3, but from the inside traffic, if you think from the inside traffic, if I ping 1.1.1.1 and I don't see any kind of translation now, because this traffic is purely local to this device, the server is a local device, this traffic is not traversing over here. So let me now try to clear crypto session. Debug crypto. ISACamp is saying, sorry, ISACamp. Debug crypto ISACamp. Let me try to ping 3.3.3. Show logging. It's okay. Show crypto ISACamp is saying. So I lost my connection. It's no traffic. Let's see what's the problem here. Show run section ISACAMP. So I have all my policies and my from I am on R1 and my peer is 20.0.0.1. I have here and I have my ACL show IP access list. So can I ping the first IP connectivity we have to check from R1? Let me try to ping 20.0.0.1. I can ping. Can I ping 3.3.3? I can ping. I have an IP connectivity. If I do trace route 3.3.3, how my packet is going. Okay. So if I give show IP route 3.3.3, directly connected. I think I got two loopback interface. Okay, show IP interface brief, exclude unassigned. The loopback here. It's 20.0.0.1. Fine. Show run face loopback 3. Config no interface loopback 3. Show run section. Show IP interface brief, exclude unassigned. Let me go ahead and here and let me delete that. Show run section. Show IP interface brief, exclude unassigned. Config no interface loopback 0. Show crypto ISACAMP AC. Show run section ISACAMP. Let's quickly delete this config and redo this. Let me delete this policy. I'm on R3. So if I give show run section ISACAMP, so I got my crypto key, delete this. Let me delete my crypto map. Let me go to the interface Ethernet 0/2 right over here. So I'm going to delete the crypto map from this interface. No crypto map. Go. Check the config. Show run section ISACAMP. Till I got one more. Config. IPSec parameter. No crypto map. ISACAMP. Deleted. Show run section ISACAMP. All my IKE phase 1 and phase 2 are deleted now. So let me create it one more time. So I'm going to use this policy. Encryption A is 256 and I'm going to use hashing SHA-256. I'm going to use a pre-shared key. The pre-shared key is Cisco and the peer IP address is 20.0.0.3. And if you look at this, this is 20.0.0.1 and this is 20.0.0.3. For me, this is the peer. So I'm going to make a peering between R3 and R1 and R1 and R3. So I'm going to copy paste this policies. We know this, we created this yesterday. So created all my phase1 parameter, all my haggles are copied. So now I'm going to do a transform set step by step. So to copy the transform set, crypto transform set. Crypto IPSec transform set. I'm giving a name Cisco, null encryption, and ESP SHA-256. ESP SHA-256 HMAC, and it should match on both ends. So I'm switching my hashing and encryption here on phase 2. Then I'm going to create a crypto map. Crypto map, the name is Cisco. I'm giving in sequence number 10. So I'm stitching my IPSec and ISACAMP phase 2 and phase 1. So I'm going to set my peer from R3. From R3, my peer is 1.1.1. Sorry, public IP address. So my peer is 20.0.0.3. Set transform set. The phase 2 parameters, the ACL, the interesting traffic, show IP access list. So in the access list, I allowed the UDP port 500, the UDP port 4500. I'll show you that. IP access list extended 100 permit UDP any traffic EQ. If you give if you look for an option here, you can give, if I give a question mark. So if you see, if I give 4500, right? So if I give 4500, I give show IP access list, show IP access list. So that is actually your non-500 ISACAM packet is your UDP port 4500 because I gave this 4500, but it converts this value something like this. Non-500 ISACAM is actually your UDP port number 500, sorry, 4500. And I allowed a traffic between the 1.1.1 right over here, this R1, and this guy 3.3.3.3. If I give show IP interface brief, exclude unassigned. So this is my source 1.1.1, and this is my destination, the 3.3.3.3. I'm on R3. I'm going to R1, show IP interface brief, exclude unassigned. I'm on R3, okay, 1.1.1, and again I'm giving here, so I have to change this. Let me make this simple. Let me delete no interface, loopback 0. So I'm just deleting this loopback interface 0 from R1. Interface loopback 0. IP address 1.1.1, 255, 255, 255, 255. Created this. So I want a loopback of 3 on this guy. No interface. Loopback 0. Loopback 1. Interface loopback 0. IP address 3.3.3. 255, 255, 255, 255/32. Show IP interface brief, exclude unassigned R3, 3.3.3, and R1. Show run section. Show IP interface brief, exclude unassigned, and loopback 1.1.1. Okay. So if I give show run section, ISACamp. So I got all my policies. This is from R1. I'm going to make a neighborship with this guy. So let me wipe out this config. So I'm going to delete my pre-shared key. Followed by that, I am going to delete my crypto map. I'm going to the interface Ethernet 0/2. No crypto map. Cisco. Do show run interface Ethernet 0/2. So it's wiped out. Only I have a NAT enabled here. Show IP interface brief, exclude unassigned. So let me check the basic IP connectivity. If I can ping 3.3.3, I can ping 3.3.3. Can I ping 20.0.0.1? Definitely I should ping. So right over here from R3, can I ping 1.1.1? Yes, I can ping. Show crypto. It's a camp SA. I haven't configured anything on R3. Show run section. It's a camp. Show run section. ISACamp. So we are in the process of deleting all the config from R1. Deleted that. Show run section. ISACamp. Config. Crypto ISACamp. Policy 10. Encryption. AES-256. Hashing SHA-256. SHA-256. Authentication pre-shared key. Diffie-Hellman group for my session keys. Group 2. Crypto ISACamp. Global config. Crypto ISACamp key. Let's go. Address. From R1, I'm going to make appearing with the outer header 20.0.0.1, 20.0.0.1. Crypto IPSec transform set. The name I'm giving as a Cisco. ESP null encryption. Phase 2 tunnel. SHA-256. HMAC. To create a crypto map. Crypto map. Map Cisco. I want to give a sequence number. I'm giving a sequence number 10. I'm stitching my phase 2 and phase 1 tunnel, IPSec and ISACAMP. Set my peer 20001. I'm on R1 20001. Set transform set. Go. Phase 2 transform set. Match address 100 to show IP access list. Access list number 100. And I have to apply this, otherwise your ISACAMP negotiation will never happen. Show run interface Ethernet 0/2. Config interface Ethernet 0/2. Crypto map name is Cisco. ISACAMP negotiation started. See here, show run interface Ethernet 0/2. Config interface Ethernet 0/2. Crypto map Cisco. So your negotiation started now. Show crypto ISACAMP SA. Show crypto session. Stays down. Debug crypto ISACAMP SA. Debug crypto ISACAMP. Show run section ISACAMP. So let me compare this. Show run section ISACAMP. So I got crypto map ISACAMP. This on R1, so I have the same policy. Policy is fine. It can be different. Then followed by that, I have an encryption AES 256. I have an encryption AES 256. I have an hash star 256. Same. The pre-shared key is fine. Both are same. I'm using Cisco. Here also I'm using Cisco. And from R1, my peer is 20.0.0.1. Correct. From my R3, my peer is 20.0.0.3. Until phase 1, it's all good. So show crypto. I say campus say I don't see any traffic. The first thing is I have to check inside my interface show run interface Ethernet 0/2. I have applied my crypto map on it, and also in R1 show run interface Ethernet 0/2. I've applied. So we are running the debug command, debug crypto ISACAMP. Debugging is on. Show IP interface brief, exclude unassigned. Can I ping show IP ARP? I have 20.0.0.3 and 20.0.0.1. Ping 20.0.0. Ping 20.0.0.1, 20.0.0.3. I can ping. My phase one negotiation is not happening. Crypto. The cam is say detail. It's not negotiating anything. My policy is fine. Set any other crypto map applied anywhere. Show run interface Ethernet 0/0. Ethernet 0/1. Okay. I don't have any problem with this. Show interface Ethernet 0/2. Crypto map is Ethernet 0/2. Oh, IP NAT site. Let me try to find, is it my NAT is causing a problem here? Interface loopback 0. Oh, IP NAT inside. So run interface loopback 0. Config loopback 0. IP NAT interface Ethernet 0/2. Oh, IP NAT outside. Show crypto is a campus C. Still clear crypto session. Why my negotiation is not happening? Show run interface Ethernet 0/2. Config no crypto map section map. Same name, crypto map. From R3, I'm trying to establish a connection to this guy. I think it looks like a bug. I should see some kind of negotiation for sure. Config. So I removed my NAT. What else? Thread 0/0. Okay, here I got a NAT here. Interface Ethernet 0/2. No crypto map. Oh, negotiation turned off, and then I'm giving a crypto map. Show crypto is a campus. Pretty strange. At least we should see states is changing. It should be no state at least. Crypto is a campus. All my parameters are fine. I have a basic IP communication for sure. Ping 1.1.1. Ping 3.3.3. Ping 20.0.0.3.0.1. Ping 1.1.1. Source loopback 0. I can ping. There is an IP communication for sure. Show run include route, because you don't have a route, then it's a problem. My VRF is creating any problem? No. So 1.1.1, I'm going to 20.0.0.3. Show run interface Ethernet. No /2. Clear crypto session. Write memory. Let me bounce the interface. Interface Ethernet 0/2 shut move shut bounce the interface on R1 interface Ethernet 0/2 shut move shut show locking show crypto IPSec campus say show crypto IPSec campus say. Okay, I think that's a bug for sure because we should at least see some kind of negotiation should happen, even though our haggle parameters are incorrect. We should at least see some kind of negotiation going on back and forth. I don't see anything here. Show IP access list is in my access list, but that comes again into my phase 2 tunnel. Why my phase 1 is not coming up? Okay, so we'll keep this aside and we'll continue the lab with a VRF. And in the meantime, let's see this comes up. We don't want to waste our time with this. Show crypto. Try to do that. Okay, so now let's move on with the VRF and we'll definitely come back to this. We'll establish the connection. We'll see then NAT from the scratch. We'll do that and we'll see. So now what I'm trying to do is I'm going to do a VRF. So I'll give you a quick background about the VRF. Okay. So in our topology, what exactly I did, this is my, I think this is my R1 router, R3. So this is my R3 router and this is my R5 router. So this has a connection back to R1, right? So when we talk about the VRF, it is called virtual routing forwarder. So the best example would be you can think like this as like your VLAN. You're creating your logical LANs using your VLANs. The same way the virtual routing is your actually your logical layer 3. Example, I would say you have one router. Yeah, you have one router and you have this interface example fast Ethernet 0/1. And this is connected to fast Ethernet 0/2 on router 5. And if you look at this, this is fast Ethernet 0/1. So you have a connection like this. So what if you have been given with you got only one router, but you have to establish your two different two different routing table. Example, you can have to make this as a OSPF pairing to this guy. Example here in R1 on R2, and you want to make a BGP pairing over this. You can do this with the normal routing protocol. Normal routing, the general routing table you have, you can still do it. But the whole point is, example, what if an ISP, right? So in our enterprise, also even in our enterprise, you have your a core switch here sitting right over here, and you have your head end router. This is your internet router, and you have a connection back to your firewall. So for the firewall, you created a two context, maybe context one and context two, right? So one is for your outbound, your internet out, and the context two is for internet in. So I cannot deploy two switches for this. So for internet out, I'm going to create an VRF. I mean, example, in the topology I'm telling, we are going to achieve a VRF in a different way there. So I'm giving an use case. So for your internet out, it comes to this VRF, that is internet out. I'll take a different color so that stands out. So when the return traffic coming from outside to inside, that hits your contacts too. That is your internet in, that goes to the firewall for inspection again. So you got two traffic here. One is your internet out, this blue line, and the internet in comes in. That is, this is your inbound. Let me take a different color. This is your inbound, and this is your outbound traffic, user traffic. So for this, I cannot deploy two devices. I cannot deploy two switches. So instead, I create a VRF, right? So the internet out routing table right over here, I'm just bisecting the switches into two pieces. So one for internet out and one for internet in with the same device. How I'm going to achieve this using a VRF. So this is VRF out and this is VRF in. So using the VRF, that is possible. So now let's do this in the lab. We'll understand this better. How to create VRF and how to do that. We'll do that. So now I'm on R3. So if I give show IP route, so if you see this, I configured an interface Ethernet 0/1. If you look at this particular interface, and I attached this interface to a different VRF. I'll show you that how to do that and how I did that. You cannot see about the 50 network, right? So that's assigned here to this interface Ethernet 0/1, but you can't see this in the global routing table. So what I gave here is show IP route. You cannot see this 50 network. So what if I give show IP route VRF R5? You see this command show IP route VRF R5. So this is, I can see the 50 network on the VRF routing table, but not in the global routing table. This is my global routing table. I don't see this 5 network, sorry, 50 network. We give this show IP interface brief. You can see this, correct? Let me draw this. So this is my router 3 and this is my router 5, correct? So I have a connection going back and forth like this. So I have a connection back here. This is going to my R1. I build an IPSec tunnel between these two. And I'm just using a static route. But from this guy, I'm running the OSPF using VRF. And right over here in R5, I'm not using a VRF. So only with this router, so I am establishing a connection with OSPF and it is a totally different routing table. So this is logically behaving as a R5. The host name is an R5. For this VRF I gave, so I gave a VRF name as R5 because this connects back to my R5 router. So it can be your an ISP or it can be your firewall, anything. So I don't want to mess up my global routing table. So I want to isolate my routing table. So for this, I'm creating a VRF routing. So the general routing table, let me use a different color that stands out better. So you got two routing table now. So one is VRF R5. This is also a routing table. And this routing table is only used for this VRF communication between R5 and R3. So in the general routing table, this R3 cannot talk to this guy. Let me show you that. From R5, I'm trying to ping. Okay, if I give show IP route, I don't see anything about even it is a directly connected, right? If you see this IP address, let me give you this show IP interface brief, exclude unassigned. If you look at this, my IP address is 50.0.0.1. If I ping 50.0.0.1, I don't see any responses back, even though it is directly connected to R3. 50.0.0.1. I cannot ping. But what if I do, if I give show IP route 50.0.0.1, it's not in my subnet. Show IP route 50, show IP route VRF. And if you give a question mark, you should give the VRF name. So before that, so how do I check my VRF? Show VRF, show VRF detail. We will do that from the beginning. We'll erase the config and we'll do that. Show VRF brief. You see this particular interface, right? Ethernet 0/1 right over here, that is attached to this VRF, and the VRF name is R5. You give show run interface Ethernet 0/1. So I enable the VRF and I gave the VRF name as R5. So you have to be very I mean, you have to pay attention to your VRF names, because if you screw up your VRF, then that's not going to work. So if I want to ping this guy, show IP route, if I give show IP route, so IP route VRF or 5 and the IP address of it. So I want to check for this guy 50.0.0.1. Is telling that directly connected with VRF keyword, with the VRF name and the IP address. But we have seen that when we give show IP route, I look for a routing in the general routing table, and I don't see that. It says that network not in the table. So what are the key points when you want to do a VRF in doing the config? I'll show you. So, and how to enable this in the OSPF. So run section OSPF. You see this, I created an OSPF. It is normally we create an OSPF without VRF. It is something like this. Just we give router OSPF and the process ID, and followed by that you'll advertise your network. But when it comes to the VRF, you have to create, you have to define your VRF. What is the VRF name? So now this OSPF is mapped out to this guy. If you give show IP route, I don't see anything about the OSPF routes. But if I give show IP route, VRF, R5, OSPF, okay, this is a directly connected. Okay, so I didn't, I mean, I'm not advertising anything from R5. That's fine. So if I give show IP route, VRF and R5, and I can see my directly connected, even the 50 network, but in the global routing table, I don't see that because I'm isolating this interface. This interface, it's behaving like this is a different router, a separate router with this interface is attached to that VRF. And let me try to establish a connection from this guy R5. So IP interface, brief, exclude unassigned. If I give show IP ARP, if I ping 50.0.0.2, I can ping. And if you see, I am not running any VRF in R1, sorry, R5. Show IP route. This is again in my normal routing table. We give show VRF brief, show IP VRF. So I'm not running any VRF. But if I go to R3 and if I give show VRF, I have this VRF created. So the point is, so I want to have an VRF only. So even you can make a pairing with the global routing table on R5. It is not necessarily you should have your VRF on R5. I have an no, I have a VRF routing on R3, but not in R5. But still, you can establish a connection between them. And now let's erase the config, and then we'll do the VRF, and let's see what should we do with that section VRF. So first you have to define your VRF name. VRF definition, I'm giving a VRF name R5. Then I'm giving a description, just a name R5. This is a description, but you have to pay attention only to your VRF name. Description, you can give anything, and you have to define your address family. We are using IPv4. We are not using IPv6. And then this VRF routing should be enabled on the interface level. Then I have to do this the VRF routing for OSPF, and then I have a static route for this 5 network. So my next hop is 50.0.0.2. Let's erase this config. No VRF. Definition R5. Show run. Section VRF. So all my VRF config has been erased. Even if you see this show IP interface brief exclude unassigned, show run interface, so IP interface brief, VRF brief, show run interface Ethernet 0/1. This guy, I mean, I'm doing this Ethernet 0/1 goes to this. So if you look at this, once I clear the VRF, all gone. Now it is not part of that. If I give, now I'm going to configure an IP address for it. But before that, I have to enable the VRF. I'm going to give VRF definition. So I'm going to create an VRF, same VRF R5. I'm going to give a description R5. And I have to define my address family IPv4. That's it really. We created a VRF R5 and we said that we are going to use an IPv4 address. And then we have to go to an interface to attach that interface. So Ethernet 0/1, Ethernet 0/1, VRF forwarding, and then we have to give a name. If you look at this, it's auto-populated R5, and I have to assign an IP address to it. IP address 50.0.0.1, 255.255.255.0/24. No shit. Show IP VRF detail, VRF brief. This interface is assigned to this. Do I see an IP address of it? Show run interface Ethernet 0/1 50.0.0.1 55.0.0.0. Fine. So let me try to ping the directly connected device 50.0.0.1. I cannot ping because that should be a part of my VRF routing table. Show run section VRF. Give ping VRF the command to ping, and it is R5 the VRF name, and then followed by the IP address, and I have to give 50.0.0.1, and I can ping. If we give 50.0.0.2, I can ping. Cannot ping 50.0.0.2. Yes, I can ping 50.0.0.2. Show IP. Show IP ARP VRF R5. See, this is a different routing, different ARP table. Show IP ARP. It's your global routing. It's your global ARP, and this is your VRF ARP details here. I can see this, and how I'm going to do this with the OSPF. I'm going to configure router OSPF 1. It will tell me that this is a VRF routing table, not the global OSPF. This is VRF. I mean, this is a VRF based OSPF. I'm giving the same name. You have to attach the same VRF name. And then if you have 10 different VRF, you can do that. So Imano is a guy, I mean, he asked a question about what is the difference between connected. To give this, this is actually advertises your classful address. So you have to give your always redistribute connected subnets, because we are using /24 for this class A address. So if you're not giving redistribute connected subnets, it will advertise only your classful address. It advertises as a /8. So that will be a problem for you. So you should always do that. Then redistribute connected. Only the 50 network I am advertising this through OSPF. And then followed by that, I'm going to create one small static route for a show IP route. For this loopback interface 5.5.5 on R5, VRF R5 5.5.5 255 255 255 255 50.0.0.2. The next hop 50.0.0.2. This guy is .2, this guy is .1. It's a 50 network right over here. My next hop is this. Can I ping ping VRF R5 VRF name and IP address 5.5.5. I can ping the loopback interface of this guy. And if okay, let's go back and see show IP OSPF neighbors directly connected. Show run section OSPF. So I have my OSPF. So let me try to ping 50.0.0.1. I'm not using any routing. I mean, VRF routing here. I can ping. Try to ping. Okay, only this particular interface is part of my VRF. So I'm just running VRF on this, and I established a connection on this. The whole objective is just we are doing a VRF, and we are trying to establish a connection between these two. And as I said, your routing table are isolated between each other. So this is how you can deploy your VRF, even though this R3 has an IPSec tunnel and I don't want to disrupt this connection. I want to make an isolate connection. So R5 and R3 are talking to a whole lot. I mean, it's talking to a different logical router, VRF R5, and this guy is talking to this, and we just made a neighborship with OSPF. You can do your BGP, where the concept remains the same. And if you want to do your BGP, it should be BGP followed by the VRF name. You have to attach your VRF to the routing protocol what you're trying to use in. So this is how you have to create your VRF, and you can do that. So the whole point is when you're running a VRF on this, it is not necessarily you should run the VRF on the remote device. It can run on the global routing table. So it is depend on your requirement. If you want to make a multiple logical routers, then you can use your VRF. Then coming back to this tunnel issue, what we had here, show crypto ISA campus. Still, I don't see any negotiation for this. So run section, second. This is on R1. Let me check in the R3 show run section. It's a camp. R3. Don't see any difference in this. The pre-shared key are same. So from I'm on R3 and from R3 my peer is 20.0.0.3. Right, show IP interface brief, exclude unassigned 3, and this is 20.0.0.1. Ping this 20.0.0.1. From R3 I can ping it. So coming back to the crypto map, this is crypto map, ISACAM key, Cisco, fine. This on R1. If I go back to R3, show run section, ISACAM. So I'm using the same key, Cisco. And the peer is 20.0.0.3 from R3. Right. My phase 1 tunnel, all the haggle parameters are fine. So run section, transform set. This one phase 2, null encryption. And if I go back here, show run section, transform set. Pressing same null encryption. Show run section, crypto map. Crypto map here is same name, Cisco. I'm giving the same name here. So running section map, Cisco. It's pretty strange. Why I can't even negotiate show crypto? Why is the campus saying? Let me reload the boxes. I should definitely see some kind of messages should be exchanged. Not even I don't think that's a something problem with this code. Show IP interface brief. Load unassigned. Show run interface Ethernet 0/2. Show crypto is a campus say. Still I don't see that. Traffic back. Okay, let me do one thing. Let me delete these notes and let me re-add this notes. Yeah, yeah. What is the question?
If I want to configure another VRF on router 3, like VRF name would be R7. Okay.
Uh-huh.
So
Okay.
on that time, I will configure in same way like VRF description. Then I enter the interface and I will configure VRF forwarding R7 like this, na?
Yeah,
Means
yeah, yeah.
if I okay, then I
I
configure another routing table with R7, right? VRF
yeah, yeah.
R7.
That's absolutely
Okay.
right. See if I give see VRF definition and if I'm creating a one more VRF R7 as you said R7 um address family IPv4 unicast. Where's the unicast? If you give show VRF brief. So I have created one more VRF, right? R7.
Hmm.
So if you give show IP route VRF R7, so I don't see anything. If I give R5, I see the 50 network, and if I give just IP route, it's a different routing table. So I got three different routing table now.
Hmm, hmm, hmm.
R5 is not attached to any interface, so once you attach an interface, it becomes a member of that particular VRF.
Yes, yes. That time I can see the interface details.
Yeah, yeah,
When I
yeah.
run show IP, what is the VRF brief
Brief,
mode?
yeah, yeah. Show
Ha, ha, ha.
IP VRF. Show VRF
Okay.
brief. Yeah.
Okay, and I have one more question regarding IPsec. Okay,
Mhm. Mhm.
if I want to configure GRE over IPsec, okay,
Mhm. Mhm.
that time what would be the difference? Means, can you tell me this? Means,
Yeah, yeah.
uh,
I mean, yeah, I'll tell you. So I have this PDF with you, so this explains you better. See, there are two type of VPN. One is route-based VPN, and another one is the policy-based VPN. So what we are doing is a policy-based VPN. If you see the traffic, whatever it is, you're actually you are very specific about your interesting traffic, your source and destination, who should talk to each other. This is
hmm,
policy-based VPN. And this route-based VPN comes in when you do your GRE. In your GRE, you
okay.
create your tunnel interface. You are just
Mm-hmm.
routing all your traffic. You're not in your GRE. You're not. I mean, my when I deployed GRE, it is just we deployed a GRE tunnels for Zscaler, and we are pushing out all the traffic to the Zscaler.
Okay.
So policy-based routing is more or less you specify your interesting traffic, whom should talk to each other. It's a LAN to LAN connection. But in the GRE, it's
Mm.
all your default route points to your destination. It depends
Okay.
on the use case. Example, if you do your DMVPN using an EIGRP and you build your tunnel, you're actually encrypting your traffic, but your routing is through your EIGRP or OSP if you're using your dynamic routing. So that is generic routing encapsulation. So You cannot do the same thing OSPF or EAGRP with site-to-site tunnel, but you can do this with the GRE, and in GRE you are just not specifying your ACLs like what we do in IPsec. There you are just building your phase one and phase two tunnels, and in the phase
Mhm.
three you are using your EIGRP or OSPF for your routing, right? That is not about
Yes.
specific about your route. See, if you want to advertise all your networks, so whomsoever your spoke as a, if he makes a pairing with your DM VPN, so he can talk to anyone, right? He can talk to all the spokes. So it depends on your config, right? So it is not about the source and destination there. So it is about a complete routing.
Gateway to gateway like this.
Yeah. So
Uh,
that is route-based VPN. This and that is route-based VPN is a GRE. The policy-based
mhm.
VPN is used for the your IPsec. You do your policy-based VPN.
Okay. And for NAT, when we are using NAT, that time we will use 4500 port number, right? Right?
Yeah, yeah,
Means
yeah, that's correct.
okay,
When
okay.
you're doing a NAT traversal, because the UDP port 4500, what happens? It will not encrypt your outer header. So it will not
Hmm.
tamper your packet. So that allows the communication over the NAT. Your communication happens using UDP port 4500.
Sir, I have wondered in some countries they have blocked for UDP 500, right?
No, it depends. And sometimes the ISP they block UDP 500 and also UDP 4500. But as I said, you have to ensure that your UDP 500, that's for your ISA camp, and for your NAT traversal, you should open your port UDP 4500.
Suppose if any country restricted this two port is not open, how they can make IPsec with those branches?
You cannot build your IPsec if you're blocking the
Yes.
UDP
I think
ports.
China blocking UDP, right?
To
500.
be honest, I am not
Hi,
sure about
hi.
that.
This is
Okay,
all
sir. Okay.
same thing. Also, I heard China block 500 port because it is not safe. That
But if they block the complete UDP 500, they cannot establish any IPsec tunnel.
Yes, something like that I also heard in because to be honest, still as I refer more sections or any documents, my conviction is getting increased in this
no,
VPN.
hello.
Yeah, yeah, yeah. We are listening to you.
Means
Yeah,
what
speak
I
up.
actually in my previous organization I saw this problem. Okay, means China block 500 pros. That time I heard they are using TCP 10,000 port for IPsec tunnel. Means I just heard. I did not build, but
No, this
I
is
heard.
all defined ports. I mean, we are not,
Huh.
we have this all well-known ports, so I don't think the protocol is designed to work on those ports. I don't know, we can change the ports. I don't think so that is possible. You can build, I haven't seen anyone build a tunnel with TCP ports. It uses UDP
TCP
500.
10,000
Yeah.
port. Huh. I heard actually in my previous
Hmm.
organization.
Okay.
Yes, I have one doubt.
Uh-huh. Yeah.
Uh, this is, in the key, you said that pre-shared key will be exchanged as a plain text, right?
Pre-shared key will be exchanged as a plain text.
Right?
Pre-shared key. No, we are using a complete encryption, right? No, nothing is plain text. I mean, until we create. No, that is the. I mean, you're talking about the pre-shared key. No, no, no. It is not a plain text. Nothing is a plain text here. Until the session key is created, your main mode messages, your haggle information that is exchanged. Until that point, nothing is encrypted. But after message 5, right? Message 4, 3, and 4. That there you actually your session key cat secret exchange happens. So after 5 and 6 are encrypted. Message 5 and 6 are encrypted, and your pre-shared key is not send it across as a clear text. That is encrypted.
The section key will be decided by the router itself, right?
By defining your Diffie-Hellman group.
Okay, okay. We have no, we cannot mention it. Okay, correct, correct, correct.
The Diffie-Hellman group decides your shared secrets.
And hello.
Yeah, 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 Deepu.
And one more thing, regarding authentication, pre-shared key I understand, but one more maybe has digital certificate. So, if possible, could you explain later classes? Means
Uh,
just give me some glimpse. Means what is digital certificate? I no need any detailed thing. Just what is digital certificate? Well, certificate. Is it possible? Otherwise, it's okay.
no, no, no. I mean, fine. So digital certificate when you open a an application, a Google.com. So there, how your PC establishes a connection with
I
that.
saw certificate. Huh?
Yeah, certificates in the same way. Here it's a public signed certificate, something you're like GoDaddy or DigiCert. If you have a digital, I mean, if you say a digital certificate, that is signed by a global CA certificate authority. So both will trust that particular certificate, but because that is a globally signed certificate, right? So both resource and no, what is that, initiate and responder both trust the certificate because that is signed by the digital certificate. But if you ask me, 95%, I mean, they don't use digital certificate deployment. They always use a pre-shared key
Appreciate.
because
Yeah.
it's very difficult. Because if the certificate expires, then you can keep your eye on that every time, and you have to renew your certificate, and then you
Okay.
have to build your tunnels again with a new certificate. That's a very tedious process and not a preferred way of doing IPsec.
Okay, sir.
Means I have to
Okay.
purchase certificate and then I install this. Means
Yes,
I have
correct,
to do
correct.
every
You
time.
have to do
Okay,
that,
okay,
yes. And then
Okay,
both device should have the same certificate for your negotiation.
okay.
sir. Sir, one
Yeah,
minute.
yeah.
If
Tell me, Akbar.
I can, if I can generate the certificate in my router itself, like a non-trusted certificate,
That is
can
self-signed
I get it?
certificate that
Yes,
cannot be
I
used.
can generate.
That certificate will not be the remote device will not trust your self-signed certificate, right?
No, no.
Because
But we
that is
can make
signed
it
by
as
your router.
no, yes. But the other party, we cannot make it like like in the exchange server. We use the local sign certificate for the clients
But that is
and
again, that is not public signed, right? See, that is
uh,
your local CA is a certificate authority for your company, not for
yes,
other
yes.
company. So that is again not valid certificate for it. You have
Even
to get
even the
it signed by the uh, public
public
CA. Public
public
CA.
that's okay. Even
Yeah.
though I can generate certificate for my company. So can I put this certificate in the host and make it a section created or not?
Sorry.
We can get the same certificate for both ends, like the private certificate. I can use it for authentication.
So see, if both device should trust your certificate, you should have the root certificate who signed your certificate on both devices. Only then it works. But how can you build a tunnel with AWS? It's not possible to. You have to give your root certificate to him, and he will not install that, right? Maybe you can use it for your what is that? Your local tunnels within the company. Maybe you can build, but I haven't tried that. You guys can hear me, or my
Yeah.
voice is
Yes, sir.
breaking?
Yes, sir. Rahul.
Okay. So any other questions, guys?
Sir, do we discuss any other VPN like Flex VPN or other type of VPN?
No, I mean, we discussed everything, but today this, I don't know, there's some problem with this router, so we'll do this in the next class for sure. We'll finish off all them, all the NAT and IPsec topics.
So then
Uh,
after that, you,
SSL, will you explain, na?
Uh,
SSL?
Sorry, what I'll explain?
SSL means I
Yes,
saw
SSL,
the
yeah, yeah, yeah,
separate.
yeah, 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 yeah.
Okay,
After this
okay,
VPN, yeah, we have a topic for SSL. Yes, yeah.
Hi, sir. Praveen.
okay.
Can you hear me, sir?
Yeah, yeah, I can hear you.
Sir,
Raju, right?
yes, sir. My name is
Yeah,
Raju. Sir, I
yes,
have
sir.
one question is on VRF, sir.
Uh-huh.
First of all, thank you so much, sir, for sharing the VRF information.
Okay, no problem.
Yes, sir. Just a
yes,
small
yes.
question, sir.
Yeah, yeah,
Yes, sir, I have created SVI VLAN for data traffic, and again, I have created VRF for voice traffic, sir.
yeah.
So,
Okay.
should I configure separate routing for SVI VLAN and VRF traffic, sir?
You have to create a.
Separate routing. For example, I am creating OSPF routing. Mm, can I configure separate routing for SVA VLAN and VRF?
Yeah, see, whatever the VRF routing you're doing, that stays within your VRF routing table. It will never leak to the global routing table unless you do. There is a command to
Okay,
leak your routes. Unless you do that, your VRF route stays within your VRF routing table. It never leaked with the other routing table.
okay. I understood.
That is isolated. That
Yeah,
behaves as a
that is
logical
also.
router. That is an isolated router. I mean, it's a logical router. They whatever the routing you run on your VRF routing, that never mess with your global routing.
Okay, understood. Sir, could you please provide the VRF syntax on our WhatsApp chat group, sir?
No, no, I will share the configuration. Yeah, tomorrow for sure.
Okay, thank you so much, sir.
No problem. No problem. So, if there is no further questions, then we can wrap up this call. We'll do the NAT labbing in the next session for sure.
Okay,
Okay,
Prabhu.
okay, guys.
Thank
Thank
you.
you, thank you. Then good
Good
night.
night.
We'll meet in
Thank
the
you,
next
next time.
weekend. Yeah, bye, bye.
Okay, thank you.
Thanks, sir. Thank
Thank
you.
you. Bye.
Yeah.